What we are doing in our lab right now is, I think for the first time, truly the first steps towards building cybernetic systems, cyborgs. You know, we've been reading about this in our science fiction for years, and it's finally starting to get there.
My entire life, I never thought that I would be where I am now, having had an amputation. I have an opportunity to engineer my own body, and I had always dreamed about that.
The implications of making a seamless connection between the body and the robot means that we end disability.
My name is Everett Lawson. I'm a research assistant at MIT in the media lab. I don't know that I would necessarily call myself an inventor, but I like to make things. And I like to make things that allow me to see and feel and experience things that I would have not otherwise been able to. I was born with a congenital clubbed foot. And what it really came down to is that the bones were weaker. So even just stepping off of a curb, I could break my foot. I remember once I was running from a bear on a dirt road and I stepped on a rock and I broke my foot.
No more. No more.
A few years ago, my wife and I found out that we were going to have our son, August. And I had reconstructive surgery to allow me to run around and chase my son and pick him up after he was born.
Oh, really? No raspberries.
And after having that surgery, I didn't heal. My leg was just absolutely deteriorating. And the surgeon said, well, we think that an amputation is going to be the best outcome for you. And I was sitting in my office, dumbstruck, and a great mentor of mine happened to come to my office and saw me sitting there. And he literally grabbed me by the arm and he said, that's it. And he took me and he marched me downstairs across the lab down into Hugh Herr's lab.
My name is Hugh Herr. I'm a professor at MIT, and I direct a research group called the Biomechatronics Group. We develop wearable robots that attach to the body mechanically and neurally. We met with Everett that day and determined that Everett would benefit from receiving the Ewing amputation.
This experimental surgery, which is a truly unique approach to performing an amputation. In a traditional amputation, not only are they cutting through the bone, but they're also cutting through all the muscles and tendons as well. In the Ewing procedure, they preserve as much of that musculature as they can and the relationship of those muscles via their tendons. I still have the musculature embedded into my limb, which means that I can have a direct neuromuscular interface with bionic limbs. And that's how I started this relationship with the Biomechatronics lab.
My name is Matt Carney. I'm a PhD candidate here in the Biomechatronics group, and I have been building bionic knees and ankles, trying to push the limits of what's actually possible to get as close as possible or even better than biological performance. What's really interesting about Everett is that because he's had this amputation, it allows him to have this neural pathway that a traditional amputation doesn't necessarily have, so that he can have direct control of the robot.
How it works is that there are sensors that read the signals coming out of the muscles in my leg, and it translates them into mechanical motion within the bionic limb. So when I fire a muscle that would say, point your foot down, it directly translates to a motion in the robotic ankle.
I think you should have control.
Range of motion for the dorsiflexion feels really good.
It does? Okay.
Yeah. I remember the first time that I saw Matt's robotic ankle, and he turned on the controls. I wasn't seeing the mechanics of this robot attached to my body. I was seeing my body being continued all the way down to a foot that had a one-to-one relationship between the thought of motion and actual motion. It was truly profound.
All right, so you can put it on. We'll try it out. We'll tune it up a little bit.
Great.
I need a little bit more resistance.
On heel strike.
Well, yes, more dampening for heel strike.
How does it feel? I just made it
That's way better.
quite a bit stiffer.
Yeah. Working with Matt and the team in the position of being a subject is a really interesting situation for me. But I also am an engineer and an inventor, and I also work on developing my own systems. And rather than trying to translate my thoughts into motion, I'm looking at how do I get sensory feedback back in. So I received this experimental surgery, which preserved a lot of the musculature of my leg, as well as portions of the nervous system. And I began to realize that there were specific spots on my leg that have an approximate sensation of the big toe, the little toe, the heel, the middle of my foot. And it was at that point that I started prototyping, building things in order to start exploring these sensations. Within the last 48 hours, I've been able to build an array of sensors that go onto the bottom of my prosthetic. They send a signal back onto my residual limb, a little bit of electricity across the surface of the skin to give the sensation of touch. So I can reach down and I can touch this one, and I have the sensation of my little toe. Whoa. August, do you want to come help Papa? Yeah. Do you want to help me do science? You want to tickle the bottom of Papa's robot foot? Oh, on the bottom, all the way on the bottom.
Sister.
I'll push that one. Whoa, I feel that. Can you push other buttons? You're touching my pinky toe and my big toe. And it actually really tickles. I hadn't thought some of this all the way through. Oh, that's live wires. August was born with bilateral clubbed feet, the condition that I had, but on both sides. The science has changed a lot, and they're able to do treatments to correct it. But sitting there as a father, looking at my son, my motivation for building bionic limbs came from thinking about the world that I want him to grow up in.
I'm going to the beach. Going to the beach.
I think it's 2019 and it's about time we got robots on people. One hope coming out of this lab is that the work we're doing allows us to push the capabilities of what the human body is even capable of doing. So that at some point, it's not just, I feel so bad that you lost your limb, here's some prosthesis. It's more like, oh, I lost my limb. Cool, look what I can do now.